Hello. We will learn simple regression model. We will implement the regression model with Python. So first go to Google and then type Google Colab. Okay. Then we can go to Google Colab and then you can start. Of course, we can also do collab.research.google.com/hashtag create equals new. Okay, collab.research.google.com/hashtag create new. And then let's make file name simple regression class. Simple regression Python class. Okay. And then first, let's import a library, NumPy library, which we will use very frequently. Import NumPy SNP. Okay, let me make it a bit larger. Okay. And then second, to make output prettier, let me reduce this one. From tabulate, import tabulate module. Okay. And then to run regression, next we will from sklearn dot linear model. Okay. And then import linear regression here. Import linear regression. This one. Okay. So control enter, then it executes. And then let's generate some arbitrary data. So X, let's make a NumPy array, NP, and then array. And then let me make data of like 1, 2, and then anything like a 2, 3, and then like 5, 7, 5, 7. It is arbitrary data. You can use whatever data you want. And then last one is a bit larger one, maybe 9, 11. Okay, 9, 11. So it is arbitrary data. So let's type X. So X looks like this. 1, 2, 2, 3, 5, 7, 9, 11. Okay. And then let's define a coefficient. Okay. So beta is a coefficient. And let's say it is MP array. And then it is one dimensional. So it is like 0.3 and 0.4. Okay. And then let's say alpha equal 3. Okay. So we are basically making model. So into the text. So what we are basically making is a model. Looks like y equals x multiplied by beta. Let's add alpha over here. Alpha plus beta. Okay. We are making model something like this. Y equal alpha plus x beta. Here, y is the vector. Basically. So to make it more looks like a vector, let's add vec. Okay. Then of course alpha is vector, but let me be less rigorous. So since it is obvious, let me reduce factor on over here. So we can define y equal here alpha plus now x multiplied. So it is matrix multiplication. So we have to do use this one. It is matrix multiplication. So beta. Okay. So let's look at the y. So y look like this. So now suppose we do not know alpha and beta. Instead, we observe x and y as data set. Our goal is to estimate alpha and beta using the data set. Okay, that's our goal. Okay, we can do it with the linear regression model. Okay, in fact, since there is no error term, we can so perfectly find the model. So let's write down regression model as a rake. Let's write the model name as a rake, and then let it run. Regression model. Let me specify this one with this one, linear regression. This one, linear regression, and then I want to fit. Okay, I want to fit y using s. We use x to fit y. Okay, that's what we are trying to do. Okay, so it is done. So let me see the result. If we see the result, then, well, let's see whether we correctly estimated the coefficient beta first. So let's print regression and the coefficient. So coefficient 0.3 and 0.4, exactly the initial one we used. And let's print, how about the alpha constant term? It is called also intercept term. So intercept, okay? So intercept term is also almost 3. So exactly recovers alpha, okay? Of course, in order to check the goodness of fit, print, we can check goodness of fit, which is regression score. Regression score. Okay. So here REG is the same to this one. This model name, regression score, and then we have X and Y. So regression score is like 1. So you have 100% fitting. It is no wonder because there is no error term. So we can perfectly fit the model, actually. Perfectly fit the model. So, and then in addition, we can predict. We can predict given X. So suppose we have a new X, X new. Suppose we have X new X, which is NP array. Let me say it is the new data is like 0, 0. What if X is all 0? Then obviously, if we believe model, X is 0, whatever it doesn't matter. Beta doesn't matter now. So alpha is 3, so Y should be 3, right? So we can check it. So print regression. Now we have to do prediction. Predict with X new. And if we do prediction, then why it is error? Why it is okay. So it is 2D, so I have to add one more. So good. So our prediction is 3. And then if we only want to see the first argument, then uh, 0, then first one, so this is 3. Okay. If it is 1 and 1, 1 and 1, let's see what happens. 1 and 1, then 1, 1, then 0 0.3, 0 0.4, so we have to add them 0 0.7 and add 3, so 3.7. It should be 3.7, right? 3.7. Of course, if it is like 10, 100, we can still generate our prediction. In that case, it's 46, right? 10 multiplied by 0.3, which is 3. 100 multiplied by 4.4, which is 40, and we add 3, so no wonder 46. Okay, and then to compare the coefficient, okay, so uh, so basically to summarize our data set, is print, tabulate, zip, and then y and x, right? So this is our data set. Given this data set, we run the regression and we estimated parameter. So we estimated parameter that generate y, and then we even made a prediction. Now let's add some error over here. Okay, so now there's no error, and then we can add error over here. So for example, we can add np random standard normal, standard normal. So the length is 1, 2, 3, 4. We have 4. So 4 error term. 4. Okay. So and then if we add error term, right? And then the coefficient is, so our data set now looks like this. So this is y, this is x, and if we run the model, this is our estimate. Okay, our estimate, and then this is intercept, and regression score is 99, but because we add error term, so we don't have a perfect estimate. So if we compare, we can print, tabulate, zip, and then let's see our initial beta and our estimated regression coefficient together. Right? The correct estimate is this one, but because we add error term, now we have different one, right? Because now we want to fit this part, because now we are gonna fit this part with this data, because we add error term. So there is no perfect fit. Okay, it is less than 1. Okay, so given this one, okay, our prediction is of course now when x is 10, x1 is 10, y1 is 100, our prediction is now 148. Okay, here again, this is our model. We add error term, so now the model looks like y equal alpha plus basically 0.3 multiplied by x1 plus 0.4 multiplied by x2. Now plus we have error term over here. Okay, so it is a correct model. Okay, but since we have only this number of data. Okay, so the estimate is not exact. So this is the very simple example of regression. Given the data set, which looks like this, very simple data set, only 4 lines of data, simple data set, we estimated basically this relationship by meaning what I'm meaning by estimation is estimating this equation means estimating the alpha and this one here beta, which is done with this path regression.